Hello friends, welcome to Complete Knowledge channel. Friends, today we will talk about Titanic. Titanic has been resting in the deeps of the ocean for more than 100 years since it sank. Now scientists are wondering if it is possible to bring the ship back to the surface. They are thinking of different way and coming up with some creative ideas like using a very large air balloons or freezing the breakage of the ship with a special freezing liquid. Let's do this video with us so that we can find out if the impossible can also become possible. But before we start, give this video a thumbs up and don't forget to click on subscribe button. Friends, let's talk about it. RMS Titanic has been on the ocean floor for more than 100 years, built more than 2 million deep in the rough water of the North Atlantic. This massive ship, the largest ever built, tragically sank after hitting an iceberg in 1912. Now, some are wondering if we can bring it back to the surface. The idea is to use huge air tanks called buoyancy tank to lift the Titanic. These tanks will be attached to the ship hulls and filled with air, which will make the whole ship lighter and push it upward. This is not easy thought. First of all, the Titanic is very big and heavy, bigger than anything built at that time. Lifting it up from such a depth, the Titanic is no longer one whole piece. It broke into two pieces. When it sank, the front and back part were laying very far from each other. We have to figure out how many tanks to use so that both pieces rise evenly. Otherwise, uneven pulling can damage the already fragile brick. Bringing these tanks down and connecting them safely, it is completely different challenge. We will need remote control underwater vehicles and skills divers to handle this delicate job. Any mistake like the separation of tank can completely ruin the end of operation. Once the tank were in place, we would need huge support vehicles on the surface to pump in all the air needed to fill them. This would require long, strong pipes and pumps and constantly monitoring everything from over 2 miles away, as you can see in the Titanic. This is an incredibly complex and challenging idea, even if it sounds simple, freezing with liquid nitrogen. The same ice that ruined the Titanic is essentially creating a giant ice storm, a giant metal keg to hold everything together and protect the Frangal Wreck require hundreds and specialized vehicles and miles of specialized pipes. But the ocean itself puts another breach in this plan. Its wetness acts like an insulator, making it incredibly difficult to freeze water quickly. Even the pressure at the depth can render liquid nitrogen useless, much like a warm palm struggles to stay warm in the cold while the Titanic is frozen in ice. The idea is rapid rise frustrating. Magnets attack iron, so some people thought that we could use powerful electromagnets to pull back piece of the Titanic. These magnets would stick to the metal part of the ship and then lift them with magnet force. This idea sounds good, but it is actually very challenging, especially because the Titanic is so deep underwater that we need incredibly strong magnets to be used to lift such heavy piece. Water pressures and corrosion make it even more difficult. Even attaching the detaching magnets without damaging the brick is difficult, especially in the dark. Lifting the Titanic could break it up even more, and sudden movements could damage the cables or dislodge the magnets. While using magnets to lift the piece sound good, but with the technology we have today, imagine a huge operation room underwater, equipped with complex robot equipment that act as scalpels and assess they have the ambitious goal of carefully cutting through the rotting brick of the RMS Titanic. The debris in the area and potential safe lift point, an attempt to raise a small section of Titanic hull in 1996 served as a reminder. The Savage company used balloons to lift a 21-ton piece, but the line broke and sent it back to sea floor. The failed operation cost 1.5 million. The technically difficult IS and the potential dangers of the underwater surgery. Control explosion on the legendary ship wreck. The original idea might seem extremely this way. They could remove part of the ship without destroying it completely. However, there are many challenges in setting of carefully measures explosion on a ship that is disintegrating underwater. The basic plan is that the Titanic could be broken into small parts scaled across the debris field. These smaller sections could then be raised more spacely. These explosions must be strong enough to break through thick steel plates but not damage the surrounding structure. A lot of planning needs to be done about where the when to detonate them. Carefully modeling and analyze is needed. Unintentional damage. Any mistake or weakness in the wreck can lead to serious problem like the ship exploding or collapsing from a purely painless explosion. The underwater environment makes things even more difficult. Shock waves work differently in water. This makes everything much more difficult to plan in very deep water. Placing explosion in the underwater wreck require people skilled in advanced technology. They must monitor the explosion in real time and have a backup plan in the case something unaccepted goes wrong. Although the idea is using explosion is carefully solving the Titanic may seem manageable on paper. The challenges is actually doing so make it a risky move. The stability of the ship, how the explosion where to place them properly, and the difficulties of operation in deep seas. This could mean that this idea remains mostly theoretical. Submarine cranes scientists have a new plan to bring the Titanic up. It's quite exciting. They want to use a special type of crane that can be go deep underwater. Norms cranes won't work because the Titanic is very deep in the ocean and is the quite heavy. This special crane is not your normal crane. It is the designed to work in extremely depth of the ocean where the pressure is very high. The Titanic is in bad conditions after being underwater more than a century. It is fragile and is falling apart. Of crane has to be carefully to hold the Titanic without causing more damage. While having a strong crane is important, it is not enough. Scientists need to control it very precisely. Like a surgeon during doing a delicate operation, the Titanic is like a fragile patient, and the crane has to lift it without making things worse and finally bring the Titanic back to the surface after so many years. Hydraulic lift system scientists are thinking of using powerful hydraulic systems that are usually used to lift heavy things. So that the plan is to put huge hydraulic jacks underneath and the Titanic that attach to the ocean floor and speed out of the lifting force using strong steel plants. Special fuel pump from ships on the surface allow a jack to slowly lift of the Titanic onto an almost underwater platform. But there is a big challenge. They need to build hydraulic jacks that can lift such a massive weight under the extreme pressure of the deep ocean. These jacks must be strong enough to overcome the resistance that the Titanic has built up over 100 years of being on the ocean floor. Placing and jacks correctly is crucial. Avoiding damaging a deteriorating Titanic going miles under the dark ocean floor is very difficult. It is like a complicated dance with a machine that can crush the steels. We might be able to float the Titanic again by lightning it is instead of lifting it. Some ideas propose filling the Titanic with buoyancy form, the pumping and the expanding form into the damaged part of the ship. It could theoretically be light enough to float. Of course, there are pockets in the form which makes them less dense. than water. If enough of the wreck is filled with the foam, it could provide the upward force needed to the lift of the 46,000-ton Titanic. However, putting this idea into practice faces serious challenges. Transporting large quantities of the expanding foam material to the site a major problem. Mixing and pumping the foam through heavy duty hoses that can withstand deep sea pressure is another challenge. When the foam injection system is set up on the sea floor, it becomes difficult to get the right distribution throughout the brick's interior. The goal is to fill empty space without weakening the structure, but the Titanic interior is a complex maze. Otherwise, methods such as pumping wakes or injecting ping pong balls have been suggested for this purpose, but each has its own set of challenges ranging from material delivery to navigated the complex internal layout of the brake lifting cables. A simple approach to lifting the Titanic involves using surface ships with powerful cranes and cables to lift the wreck. Despite its apparent simplicity, the method has considerable challenges. Lifting the Titanic massive 46,000-ton weight from extremely depths required cables and cranes with exceptional strength and capacity. These cables are made of materials such as ultra high molecular weight polythene which restricts corrosion and pressure. The surface cranes required to lift of the thousands of tons would be world largest marine service cranes mounted on specialized heavy lift vessels. Successfully executing this plan would require safely adding multiple lifting points onto the deteriorating embankment faces. Synchronization of advanced submersible submersible robots and divers is crucial during the lift. Uniform speed in lifting cables prevent dangers bending or tensions. Achieving lift symmetry from various attachment points on the century old rig demands real time monitoring and adjustment. That all this video give us a thumbs up to let us know if you enjoy learning about the challenges of lifting the Titanic. Share this video with anyone who might find it interesting, and don't forget to subscribe the channel more such amazing videos. So please guys subscribe my channel Complete Knowledge, and thanks for the watching this video. Thank you.